done in the
yeah.
month of July, then it would have been much more interesting.
Yeah. Anyway, next semester, all of you will be forced to come to campus. Don't worry. Right. Okay, let's move on to the last unit of our data mining. I had posted a assignment in the GCR. Please make a note of it and please work on it. And now moving on to the last unit. So last unit is all about outliers, outlier detection methods, outlier analysis or anomaly detection. That's what the last unit is all about. Okay, outlier or anomaly. So what are all the data mining techniques that can help us to detect spurious or suspicious transaction? Okay, that's the first part of the fifth unit. Then second part of the fifth unit is all data mining applications. Few two or three case studies are given, which will help us to understand uh, the flow of data mining what we had in all the five units. So that's what the second unit is all about. Okay, so let's start with what basically is outlier. Outlier, what basically is an outlier? Okay, so if you open any data mining book or any tutorial, any discussion on outlier starts with an example, and that example will be a classic example from the credit card company. Credit card company, fraud detection is the classic example being quoted everywhere. So let me also give you the same example, which is the most popular and the standard example. Okay, so let's imagine that you're working for a credit card company and that you are the transaction auditor. Okay, so to protect your customers from credit card fraud, okay, so uh, as a transaction manager, you might start paying some extra attention to the card transactions or the card usage. Okay, and you might start tracking those transactions that are different from the regular or the normal transactions. Okay, for example, if the purchase amount is much bigger than the usual ones which is being done by the card owner, or if the purchase is occurring at a totally different alien location, which is far away from the owner's residence city or from where the usual transactions happen. Okay, so those kind of purchases can be suspicious. Okay, so as the transaction auditor or the auditor manager, you want to detect such transactions whenever they occur, and you want to contact the credit card owner for verification and authentication. Okay, so this is actually a common practice which is being done by many credit card companies. Oh, they are coming. Let right. Hold on, please. My offline students have come. Let me settle with them first. Sorry for the interruption. Uh, I was just welcoming our friends in the class. Mhm. Is the PPT visible? Yeah, I was just telling you. what outliers are. I hope the PPT is visible, right? Is it visible? Can somebody uh, confirm, please? It's visible, right? Okay, at least my offline students are telling me. Okay, so I was just telling you the case of a credit card company, and the case of rare transactions or rare events happening. Okay, unusually large transactions, or transactions which are being done from an alien location, which doesn't look too authentic to the card owner. Okay, so as a transaction auditor or as a manager, you would always want your customers to be notified about such transactions. Okay, so in the case of credit card fraud detection and other things, the rare events, I just told you, the rare transactions which happen, or the rare locations at which the transactions happening, okay, they are more interesting than the regularly occurring ones. Okay, so the outlier analysis or anomaly detection becomes very significant in such cases. Okay, so that's the significance of outlier analysis or outlier detection. So outlier, as shown in the PPT, it can be explained as a piece of data or an observation, okay, as mentioned in the PPT, that deviates from the regular data set or from the normal data set. Okay, so when you say an outlier, it could be by a chance. Outlier could be by a chance, or it could be due to some measurement error, or some variability in the measurement. Okay, so and it can be due to multiple reasons. Okay, so as far as any business is concerned, okay, it's very much significant for the outliers to be quickly detected and analyzed, so that you can adjust your course of action and ensure that your revenues are getting generated and you're able to avoid the losses. Okay, so that's the significance of outlier analysis or anomaly detection. Okay, the process of detecting and subsequently not just detecting, even excluding those outliers from the given set of data. That's what is outlier detection all about. Okay, so uh, that's regarding the definition given here for outlier. And as told here in the second point, you can see here the second point, outliers are different from the noisy data. Okay, in the sense, outliers are different from the noisy data. And again, the noise is also something which is not interested or required in data analysis. Okay, including your outlier detection, noise is something which is of not interest. For example, in the case of a credit card fraud detection, okay, so you can model your customers purchase behavior. Okay, that can be modeled as a random variable, and then the customer may generate some noisy transaction in the sense, it may not be an outlier. For example, that particular customer would have had a special lunch on a particular day, so that is not the regular thing what he has on a daily basis, a special lunch, or he would have had an ice cream or something which is not a regular pattern. Okay, so that is not an outlier. Actually, that is not an outlier. That's an example for a noisy data, a noise which is being generated by the a noisy transaction which is being generated. Okay, so such transactions, having a special meal or having something extra, all these things should not be treated as a outlier. Okay, because if you start otherwise what will happen is, for example, if it is the credit card company, so they will have to spend a lot of time to verify each and every transaction. Okay, and then they will have to bother the customer every time, and give them false alarms. Naturally, the customers will start getting irritated, because that's not an outlier, it's just a noisy data. Okay, so noise should also be removed as a part of outlier detection. Before you go for anomaly detection or outlier detection, so noisy data should also be removed from data mining. Okay, so that's what outliers and noise is all about. Outlier is different and noise is different. I gave you an example for an outlier and a noise. Okay, so outliers are interesting. It violates the mechanism that generates the normal data. Okay, so these are the regular applications of general popular applications of outlier analysis. The popular one is credit card fraud detection, the one which I have given in the class just now. Then we have the telecom fraud detection, customer segmentation, be it medical analysis. Everywhere, outliers, detecting outliers is more interesting. Okay, so some pictures which will help you to understand the outliers, the one which doesn't go with the normal pattern of the group. That's what is being shown here. So outliers matter. Even in a normal distribution curve, we can see the outliers out here. Okay, so that's what outlier is. Okay, so now, okay. So outlier detection and our clustering, what we had learned in the fourth unit. Okay, so you can say they are both highly related tasks. Okay, so when you say clustering, clustering is all about finding some uh, majority patterns in the data set, and you organize them accordingly. But then when you say outlier detection, it's all about finding some exceptional cases that deviate from the majority pattern. That's what outlier detection is all about. Okay, but then they both serve different purpose. But then using your clustering techniques, whatever we have learned in the fourth unit, it can be even used for a outlier analysis purpose. That's what I've given here. The k-means clustering algorithm is what you have learned in the fourth unit is being mentioned here. Okay, so in k-means clustering, what you do is, so you, I mean, each cluster has got an average value or a mean value. Okay, so objects belonging to the cluster whose average value is closest to it. So that's how you go for clustering. Okay, so in order to identify the outlier, so what you will do is, first you will initialize some sort of threshold value, such that any distance of any data point greater than the threshold, okay, than from its nearest cluster, so that can be identified as a outlier. Okay, then of course you need to find the distance of the test data to each cluster average. And if the distance between the test data and the closest cluster, if it's greater than the threshold value, then you can easily classify it as an outlier. So that's what I've just modified the k-means clustering technique just to show you that I mean, how an outlier can be detected. Okay, so when you say outlier, so there I said the outliers can be due to different reasons. It could be due to some measurement error. The instrument which is measuring the data is at faulty, so due to which an outlier can occur. Or it could be some data entry error, human error, or it can be some data extraction error, that is experimental error. Okay, or intentionally errors are being introduced for testing purpose before it's being deployed onto the set. Okay, or it could be some data processing error. So it can be due to multiple reason, or it can be due to some sampling error also, because when we consider a data set, we don't consider the entire population. We just draw a random sample from it and then do the analysis. So sampling errors can also occur, or biasing. Okay, so all these things can be the cause of outlier or error, or it can be a natural error. Okay, so I mean a natural outlier or an error. So all these are the reasons. Okay, so now looking into the different types of outliers. Okay, so types of outliers, you have three types of outliers. The first one is what is called the global outlier. The second one is what is called the contextual outlier. Third one is what is called the collective outlier. Collective outlier. So the first one, let's see, mentioned here, the global outlier. Okay, so global outlier, you can see here, which is also called point anomaly. It's something which deviates, an error which deviates significantly from the rest of the data. It's deviating significantly from the rest of the data. You can say, I mean, they are single data points. You can see here a single red dot out here as an outlier. Okay, a single data point that will be lying far from the rest of the distribution. Okay, so that's when we call it as a global outlier. Okay, so when it comes to a global outlier, either it will have a very high value or a very low value relative to the other values in the data set. Okay, so that's when we call it as a global outlier. For example, okay, let's say you have 10 points. So 9 out of the 10 points are having a value between, let's say, 20 and 30. But then the 10th point is having a value called 85. Okay, so in that case, the 10th point will be the global outlier. Okay, so that's not in accordance with the norm of the group. So that's what we call it as a global outlier. You can see here a global outlier, which is either a very high value or a very low value from that is significantly different from the normal data set or the normal distribution. That's when we call it as a global outlier. Okay, so then here the red dot out here, or the region which is being earmarked with a circle out here, that's an example for a global outlier. Then we have what is called the contextual outlier. Contextual outlier is nothing but the conditional outlier. Okay, conditional outlier. Uh, based on the context. Based on the context. Okay, so that that particular individual data point will be different in certain context, in some specific context or in some specific condition. So then we call it as a contextual outlier. For example, based on the time, or based on the location. Then the characteristics of the object will change. For example, if it's temperature, temperature, when you say 25 degrees Celsius or centigrade, depending upon whether it is too hot or too cold, depends on whether it is a summer or whether it is a winter, or which part of the country you are looking into, whether it is Canada or Chennai. Okay, so based on that it varies. So that's when we call it as a contextual outlier. Okay, defines the context based on the time, the location, and various other characteristics. Okay, so then yeah, so that's what the example given here in the PPT is also temperature. When you say temperature is 28 degrees Celsius, okay, so whether it is an exceptional temperature, whether it is an outlier value is the question which will be given to us. Okay, so that whether 28 degrees Celsius as a temperature is an outlier depends on the time and location. Okay, so for example, if it's in Toronto in Canada, and if it is winter, definitely it is an outlier. 28 degrees Celsius will be a centigrade would be an outlier. Okay, but then if it is the same place, Toronto and Canada, and if it's a summer season, it would be a normal temperature. Okay, so that's what is called a contextual outlier. Okay, so how to define or formulate meaningful context for that particular attribute is the issue as far as a contextual or a conditional outlier is concerned. Okay, so it can be viewed as a generalization of local outliers whose density significantly deviates from its local area. Okay, so next case is the third type of outlier is what is called the collective outlier. Okay, collective outlier. Okay, so a subset of data objects collectively deviate significantly from the whole data set, even if the individual objects may not be outliers. For example, let's say the stock price. All of you are aware of the stock market prices. Okay, so that's something which keeps on changing. Even every second it keeps on changing. So for example, if the stock price is not changing at all, even for even a 0.000 value, if it is not changing for a long time, okay, so then we could call it it could be a case of collective outlier, because for any publicly traded company stock, so that will never be the stock value will never be a static thing. Okay, so there are minute fluctuations every now and then based on so many factors over a period of time. Okay, so that could be example for a collective outlier. Okay, or otherwise, let's say you are the manager of a supply chain supply chain organization, and you are a person who's responsible for handling say thousands of shipments and orders every day. Okay, so if one particular order of that particular shipment is being delayed, okay, so then you cannot treat it as an outlier, because definitely delays can occur from time to time. Okay, so that cannot be treated as an outlier. But then on the other hand, if those 1,000 orders are being delayed, okay, due to some reason, okay, on a single day, okay, so that 1,000 orders as a bunch, as a collection, will be treated as an outlier. So that's an example for a collective outlier. Okay, so though one particular order is delayed or something, we cannot treat it as an outlier. Maybe that could be a noise or something. But then on the whole, when all this 1,000 bunch of transactions get delayed, that could be treated as an outlier, which is an example for a collective outlier. Okay. Then another application which is being mentioned here is intrusion detection. Okay, when a number of computers keep sending denial of service packages to each other, the DOS attack happening or denial of service attack happening, a number of computers are reporting, definitely it's an example for a collective outlier. But then one particular not responsive or other things, it could be treated as a noise. Okay, so that's regarding the third one. Okay, so the collective outlier, a data set may have multiple types of outlier, and one object may belong to more than one type of outlier. Okay, so these are the different types of outliers. Are you all listening? All my offline students are listening. What about my online students? Who and all are sitting in the class? Selva Niklesh is there, Sharan Varghese is there, then Anand. Aravind. Okay. Aravind is roll number 17, Aravind. 17, Aravind. Okay. See, 4 of my students are listening. What about remaining 50? Only 49 are there in the class. Okay, fine. As usual, everybody is sleeping. Okay, so these are the types of outliers. I hope it's understood what's a global outlier, what is a contextual outlier or a conditional outlier, and the third one is the case of a collective outlier. Okay, so now let's see what are the difficulties or challenges involved in outlier detection. Okay, challenges involved in outlier detection, because outlier detection or anomaly detection is a very popular area in data mining. It's got a lot of applications, but then it do have its own set of challenges. So these are the 4 points which are being earmarked here. The first one is modeling normal objects and outliers properly, earmarking them or modeling them appropriately. Because outlier detection, the quality of your anomaly detection or outlier detection, so that depends on how you model your normal objects and your outliers, that is the not normal, the non-normal or the outlier objects. Because many a times it is very difficult to enumerate all the possible normal behavior for a particular application. Okay, and then many a times the differentiation or the border point between a normal and a outlier, okay, so it may not be a clear cut one. Okay, so it's something which is very little bit difficult to deal with. Okay, so in the case of certain methods, okay, for a particular object, so they may clearly earmark it as normal and outlier, whereas for certain other techniques, outlier detection techniques, rather than a hard boundary like normal and outlier, they go for each object would be assigned with some sort of score, score value. You measure the outlierness or the normalness of a particular object. So some sort of score will be assigned to the particular object. So it varies from application to application and outlier detection method to method. Okay, so that's what the first point is all about, modeling normal objects and outliers properly. Okay, so the border between the normal and the outlier objects is often a gray area, difficult to distinguish between both. Second one is application specific outlier detection. Okay, so that's what it varies from application to application. It's given here in a clinical example, clinical data. So in clinical data analysis, okay, so a small deviation, could be thought as an outlier. Okay, so a small deviation from the normal data set could become a outlier. Whereas if you take a marketing analysis or a marketing segmentation, okay, so objects are subject to much more larger fluctuations or changes. Okay, so those larger fluctuations or changes are necessary to substantiate what we call as an outlier. So it varies from application to application. That's what I wanted to tell you. Okay, application specific outlier detection. Okay, so the choice of distance measure among objects and the model of relationship among the objects are often application dependent. Okay, then the third one is handling noise in outlier detection. Okay, so I told you outlier is different from noise, and noise is something which might distort the normal objects, and it will blur the distinction between normal objects and their outlier. It may help to hide the outliers and reduce the effectiveness of outlier detection. So before performing an outlier detection, it's very, very essential to remove the noises from the data. I gave you the example in the credit card fraud detection case. Okay, a customer who has a regular lunch daily, one particular day he goes and has a special lunch, that cannot be treated as an outlier. Okay, so that's an example for a noisy data. So that should be detected, it should be taken care, and it should be removed before you go for your anomaly detection technique. Otherwise, every time the customer has a special lunch, and if you start signaling to the customer that, to the owner of the credit card, that it's a spurious transaction, he'll definitely be irritated. Okay, he will not be interested in doing that. It will be a case of false alarm. Okay, so handling noise in outlier detection is also very, very important. Then the last point is understandability. Okay, so yeah, so in certain application scenarios, okay, so the user may want to not just detect the outlier, but understand why the detected object is an outlier. Okay, so to meet with the understandability requirement, so your outlier detection method, whatever is under consideration, should provide some justification for the particular detection being done. Okay, so specify the degree of an outlier, the unlikelihood of the object being generated by a normal mechanism. Okay, understand why this is a outlier and provide a justification for the outlier. So that's also a tough thing. So these are the challenges involved in outlier detection. Okay, so modeling the normal objects, application-specific outlier detection, handling the noise, and understandability. Okay, so that's the first part of your fifth unit, which starts with outlier and outlier analysis. What basically is an outlier? How is it different from a noisy data? I gave you an example for a credit card fraud company and how it takes care of noisy data and outlier, the application domains of outlier, and then yeah, I mean, how clustering is closely related to outlier detection and how your k-means algorithm is being modified to detect the case of an outlier. Then the different types of outliers, where we had three categories. First one is what is called the global outlier. Then we had what is called the contextual outlier. And third one is what is called the collective outlier. Collective outlier. Then what are the challenges in outlier detection? Okay, so next we move on to the next topic. So next is the second topic is the outlier detection methods. Okay, outlier detection methods. Okay, so the outlier detection methods are being categorized into two. First, depending upon whether the sample of data, what is being considered for analysis, is given with domain expert provided labels that can be used to build a outlier detection model. Based on that, we have three types. First one is what is called a supervised model. Second one is what is called unsupervised model. And the third one is what is called a semi-supervised outlier method. The second one is we divide the method into groups according to their assumptions regarding the normal object versus outliers. So based on that, we have the statistical method, the proximity based method, and the clustering method. Okay, clustering method I've shown in red color because it's not mentioned in your syllabus. We will be discussing only the statistical method and proximity method. So that will complete the first half of the in fact, the 3/4 of your 5th unit. And the second half is all about applications of data mining, where we have to take up 3 case studies. That's it. Okay, so with that, we'll be winding up the portions. So these are the different outlier detection methods. My online students are listening? Rakesh? As usual, no. Rakesh, why you didn't come to campus today? The other day you came? Rakesh is not there, huh? Or he will open his mouth only for attendance. Nishok is listening. Nishok VG?
Yes, ma'am.
Okay, thank you, Nishok. Jevora?
Yes, ma'am.
Okay. So only Rakesh is not listening. Rest everybody are listening. Sriram. Sriram has personally
Yes,
made a
ma'am.
request to me not to call out his name. Correct, no, Sriram? He personally came here and told me not to call out his name. So let me not call out. So actually, the offline students are asking me to call out your name. That's why I called you, Sriram. Okay. So let's get back to our.
Ma'am,
Yeah, who's this?
I'm
Rakesh.
Rakesh.
Oh,
Yes,
yes, Rakesh. Just now got up from sleep, or somebody called you. Somebody gave you a missed call and you got up and connected back to class.
No, ma'am, no, ma'am.
Then
Got
why, Rakesh?
disconnected.
Got disconnected. Yeah. Every time I call you, you get disconnected. I know that.
Excuse me, ma'am.
Yeah. Who's this?
Ma'am, Sheena, ma'am. Did you call me, ma'am?
Yeah, Sriram. Just now only you heard from me. I called you
Ma'am,
2
no,
minutes
ma'am.
back.
I wasn't wearing my headphone, ma'am. Yes,
Okay.
ma'am.
Actually, the offline student sitting here made a request to me to call out your name. So that's why I called out your name.
Who, ma'am?
No, don't go bash them. They're all my good students sitting here. Let me not tell their names. Okay, let's come back to the class. Fine.
All right.
We'll call their names when we come offline.
Yeah, definitely, Anirudh.
Yes.
We'll do that. I was expecting you in class. Okay, fine. So we have outlier detection methods, 2 categories. The first with these methods, and the second with these methods. Okay, so we'll just have a look at. Okay, so we'll start with the first category where we have the supervised, unsupervised, and semi-supervised methods. Okay, the names and the definitions are very well familiar to you. Supervised methods, outlier detection method, supervised method. Okay, so you're well aware that when you say supervised learning, so it's a scenario in which the model is being trained on the labeled data, and the trained model will predict the future data or the unseen data. So that's what your supervised learning is all about. Okay, so the supervised methods will model the data, normality and abnormality. It's all about classification, yes or no. Okay, so the domain experts will examine and label a sample of the underlying data. Okay, so it's being classified as a modeled as a classification problem. Okay, so the task is to learn a classifier that can recognize outliers. Okay, I know it is not that easy when I say all these things, rather than practically doing an example or dealing with an application and learning. So that's something different. Maybe you will get a chance next semester or so, maybe when you start learning your AI, artificial intelligence. We do have ML topics there. So then we could do it. Okay, so as of now, we don't have a lab with this. Okay, so the task is to learn a classifier that can recognize outliers. Okay, so the sample is used for training as well as for testing. Okay, so in some applications, the experts may label just the normal objects, and any other object which is not matching the model of the normal object will be reported as or plotted as an outlier. Okay, so there are some other methods that will model the outlier and treat objects which is not matching the model of the outliers as normal. So either way, it is a classification. Okay, so that's what the supervised learning is all about. Then the second one is the unsupervised method. Okay, so when you say unsupervised method, whatever you learned about clustering, no labels are presented for data to train upon. That's when we call it as an unsupervised learning. Okay, so the objects labeled as normal or outlier, they are not available to you. Okay, I hope you remember I gave a Tom and Jerry picture and explained the difference between supervised and unsupervised learning. Okay, so in such cases, we cannot go for a supervised method. Okay, so many of the clustering methods, whatever we have learned, it can be adapted to act as a unsupervised outlier detection method. Okay, so the basic concept is you first find the clusters and then the data objects which is not belonging to the clusters, that will be plotted as a outlier. Okay, but then though we theoretically tell all these things, there are issues associated with it. The first is the data object not belonging to any cluster may be a noise. It could be a noisy data instead of an outlier data. So that could be first issue which has to be dealt with. Okay, the second is then it's quite expensive to find the clusters and then find the outliers. Because after you apply the clustering technique and then go for outlier detection, of course, it's a tedious process and a costly process. Okay, so these are the two things to be dealt with. Okay, so I mean, each of these methodologies, be it supervised or unsupervised, it has its own set of advantages and disadvantages. Okay, for example, if it's a supervised learning model, it will definitely produce high accurate results. Whereas if it is an unsupervised learning, I mean, as everybody knows, they don't improve over a period of time. Okay, your clustering and other things. Okay, so one rule of thumb or one thumb rule, I mean, which can be considered for outlier detection is, okay, so any data point or any sample which is falling, let's say, beyond the 99th percentile. I hope you remember we discussed about percentiles, quartiles, quantiles, and percentiles, I think, in second unit, right? Measures of central tendency and measures of dispersion. When we learned about measures of dispersion, we learned about quartiles and quantiles. 10th quantile, 25th, 50th, which is nothing but the median. So in this case, any point which is falling beyond the 99th percentile, okay, so that data point can be classified as an anomaly, okay, using the unsupervised learning. Okay, but then that method is also actually a very tedious and a trivial method. Okay, but then that's a rule of thumb which is generally followed in many applications. Okay, the data point which is lying beyond the 99th percentile is always earmarked as a outlier. Okay, so that's regarding the supervised and unsupervised learning. Then of course we do have one more called semi-supervised learning. Semi-supervised learning. Okay, so where I mean, in many applications, although obtaining some labeled examples is feasible, the number of such labeled examples could be small. Okay, so we could encounter cases where only a small set of normal or outlier objects are labeled, but then a majority of them is unlabeled. Okay, so in such case, we need to go for what is called your semi-supervised learning methods. Okay, so when the labeled normal objects are available, you can use them together with unlabeled objects that are close by to train a model for the normal object. And the model of normal object can then be used to detect the outliers. Okay, so the ones that are not fitting into the normal objects, and they can be earmarked as outliers. So a combination, a semi-supervised learning model for outlier detection. Okay, so coming to the, that's the, this is what we have just completed: supervised, semi-supervised, and unsupervised. So next, moving on to the second type. Second type, nothing but statistical method. Okay, so based on the assumptions. Okay, so statistical methods. So you can see here, an example is being given here. You can use the Gaussian distribution to model the normal data. Oh, okay. Gaussian distribution to model the normal data, because Gaussian distribution and Gaussian process, it's something which is very useful in statistical modeling, because it is closely synchronized with your normal distribution. Okay, so detecting outliers using a statistical Gaussian model. You can see here a picture is being given here. So yeah, so the Gaussian distribution can be used to model the normal data. Okay, so that is most of the data points in the particular set will come under that. Okay, so I mean, I mean, when you try to, that's what you can use Gaussian distribution to model the normal data, and which will help you to detect the outliers. So see, Gaussian distribution GD of Y. Y is actually the one which belongs to R, this part. R is the outlier. Okay, so Y is unlikely generated by the Gaussian model, so thus an outlier. Okay, so the probability is very low. Whatever is being generated by the outlier, the Gaussian distribution, treated as an outlier. Okay, so when you say statistical models, so the statistical models, it's also called model-based methods. So they assume that the normal data follows some statistical model. Okay, so the data not following the model will be treated as an outlier. Okay, and Gaussian distribution process is used to model the normal data. And again, the effectiveness of the statistical model depends on whether the assumption of statistical model holds in the real data. Okay, of course, there are so many other alternatives to it also. You have what is called the parametric method and the non-parametric method also, which should be looked into. Okay, so that's what is the statistical modeling all about. The next is actually the proximity-based method. Proximity-based method is the proximity. What is proximity? The nearness. Okay, the nearness. Okay, an object is an outlier if the nearest neighbor of the object is far away. Okay, that is, the proximity of the object is significantly deviating from the proximity of most of the other objects in the same data set. Okay, so that's when we call it as an outlier. Okay, so that's what the proximity based method is all about. Okay, so the effectiveness of the proximity based method relies on the proximity measure. Okay, so for some applications, the proximity or the distance measures can be obtained easily, but then others have a difficulty in finding a group of outliers which stay close to each other. Okay, so there are actually two proximity based outlier detection methods. One is what is called the distance based method, and the second one is what is called density based method. Of course, you don't have all those things in detail, so it's just a brief about all these methods. So with that, I'm stopping for today. So next class we'll start with the statistical approach in detail. The statistical approach in detail has to be dealt with. Fine, let me take attendance. We have a please answer your attendance. Anirudh,
Present, ma'am.
Dharini,
Present, ma'am.
Ramharini,
Present, ma'am.
Kalyan Sundar,
Present, ma'am.
Aravind is here. Okay, Sharan Varghese is also here. Shakti Priya,
Present, ma'am.
Nishok,
Present, ma'am.
Shreya.
Present, ma'am.
Shreya was absent for previous class.
Yes, ma'am.
Suveda,
Present, ma'am.
Vishal Bhashyam.
Present, ma'am. Present, ma'am.
Yeah. Noted. Somebody is texting me out here. Okay, let me stop recording.